Okay. Sir, is it audible?
Yes, sir, audible.
Okay, sir. Okay, sir. Okay. Uh, we have started with force voltage analogy and force current analogy of mechanical translational system, force voltage analogy and force current analogy. That is, we review few things of previous class. That is, in force voltage analogy, mechanical system force is the input, electrical system voltage is the input, and output is velocity or displacement in case of mechanical translational system, and current or charge Q is the output in case of electrical system. Dissipative element is dash part in case of mechanical system and resistance in case of electrical system. And storage element, mass is the storage element. Mass and springs are storage elements. For mass, the equivalent in force voltage analogy is inductance, and stiffness of spring K, it is reciprocal of capacitance. Okay, and physical law governing the mechanical translational system. Mechanical system is Newton's second law, and same for electrical system is Kirchhoff's voltage law. So this is for analogous quantities of force voltage analogy. And force current analogy, there is a slight difference. That is, input is force in case of mechanical system, and electrical system, it is current, I. Force current analogy. I'm talking about force current analogy. And dependent variable, velocity, and voltage is the output. And if you use displacement, flux is the output. Dissipative element, that is dash part is the dissipative element, and conductance 1 by R is the dissipative element in case of electrical system. Storage element, mass and springs are storage elements. So mass, the equivalent is capacitance C, and stiffness of spring K, inverse of inductance 1 by L. And the physical law governing the system is Newton's second law and Kirchhoff's current law in case of electrical system. And we have started with a problem. All of you please refer your note. We write the equation for the system. That is, we have derived force voltage analogy. Force voltage analogous circuit. So here we have derived at last we ended up with the circuit like this for the previous problem. Okay. So force voltage electrical analogous circuit. These two circuits are same. Refer your note and tell me. Somebody can answer. Somebody can answer. Refer your note and tell me if the circuits are same. MG Bharat, the circuit is same. Hello?
Yes, sir.
Same circuit you have.
Yes, sir.
Okay. So now we write mesh equation for the circuit. Mesh equation. So mesh equation, we use voltage equation. Just a moment, my audio is low. I'm checking it. Okay. So L1 dI1 by dt, that is voltage across the inductor L1. And this is R1, L2, R2, C2, R1 to C1. Okay. So L1 dI1 by dt plus R1 I1 plus R12. Please listen. Current I1 is flowing through L1 R1. Okay. And I2, here we have another current. I2 will be flowing through L2 R2 C2. Okay. And these two elements will have both the currents I1 and I2. I1 and I2. Okay. these two elements, because these two elements are common to both I1 and I2. So these two elements will have both the currents. And when we write the loop equation or mesh equation for this loop, we need to consider this is positive, or I will tell you how we are making it. So R12, I1 minus I2, I1 minus I2. Okay, because both the currents are flowing in clockwise direction. Clockwise direction. Okay, please listen. Current I1 in this arm flow in this direction. This is the I1 direction. And I2 will be flowing in this direction because this is a closed path. Okay, I2 will be is, please listen, I1 downwards, I2 upwards. So this is positive and this is negative. R12, okay, C1, 1 by C1, integral I1 minus I2 dt is equal to, this is please listen. So there in mechanical translational system, when we write the force balance equation using Newton's second law, we consider opposing force by each element. Okay, each element. So here we have to consider the voltage across each element. Voltage across each element. The voltage across L1 is L1 dI1 by dt, and the voltage across R1 is R1 I1. The voltage across R12 is R12 into I1 minus I2. And the voltage across capacitor is C1 is 1 by C1 integral I1 minus I2 dt. So what is the applied voltage here? What is the applied voltage? Sorry, applied voltage.
E of t.
What is the applied voltage? Hello?
E of t, sir.
EFT. Just a moment. I check it.
Hello? Can you hear my voice now? Can you hear? Hello?
Yes, sir. Audible, sir.
Audible. I'm not hearing your voice. Now,
Sir, voice is not audible.
now is it okay, sir?
No, sir.
Echo.
Some disturbance occurs.
Hello? Just a moment. Is it audible, sir, now?
சார் ரொம்ப உள்ள இருந்து கேக்குற மாதிரி இருக்கு. ப்ளூடூத் செக் பண்ணுங்க சார், அது ஆஃப் ஆயிருச்சா என்னமோ.
Now, sir, is it audible?
Yes, sir. Yes, sir. Okay. Now.
Hello, sir.
Yes, sir. Audible, sir.
Hello, sir. Is it audible?
Yes, sir. Audible.
Hello.
Sir, கேக்குது.
Is it audible, sir?
Yes, sir.
I am not hearing.
கேக்குதுங்களா?
Hello, sir.
Sir, audible.
Hello. Hello, sir.
Sir, கேக்குதுங்க சார்.
கேக்குதுங்க சார்.
இப்ப கேக்குது சார், கிளீனா கேக்குது. ஓகே சார், ஓகே சார். Right, sir. We will continue, sir. So, L1 di1 by dt plus R1 I1 plus R12 I1 minus I2 plus 1 by C1 integral I1 minus I2 dt. What is the applied voltage here? Applied voltage is E of t. Applied voltage is E of t. Okay. This is this loop 1. For loop 2, we start with L2. L2 di2 by dt plus R2 I2 plus 1 by C2 integral I2 dt plus R12 I2 minus I1 plus 1 by C1 integral I2 minus I1 dt equal to 0. Okay, are the two equations. Now, all of you compare this equation with the mechanical equation 1. Students, can you hear me? Hello?
Yes, sir.
Can you hear me? Hello?
Yes, sir. Audible.
Somebody can
Hello,
answer.
sir. Yes, sir.
Somebody can unmute and answer. Yeah. Hello?
Sir.
Yeah. Now you compare this first equation, loop equation 1 for the equation mechanical equation. There is your Sam echo. I am hearing echo. Okay. So M1 d square x1 by d square. Please listen to your note. It is available in your note. M1 d square x1 by dt square. If I replace this with displacement, so that also we have written there. Bottom, you see M1 dV1 by dt. Please refer to your note. M1 dV1 v1 by dt plus b1 v1 b1 v1 b12 b12 v1 minus v2. That v1 in mechanical equation is velocity. So 1 by c1 integral 1 by c1 here 1 by c1 there it was k1, it is k1 into integral v1 minus v2 dt equal to f of t. So that is called, this is called analogy. This is called analogy. These two circuits are analogous. These two circuits are analogous. Similarly, for second equation, you refer the mechanical equation m2 dv2, that we have written or not? Somebody can answer?
Yes, sir.
Hello?
Yes, sir.
Second equation.
Yes, sir.
Hello?
Yes, sir.
Second equation. Hello?
Written, sir.
Yeah, I will call somebody. Dharanish, you read the second equation. Dharanish? Hello? Can you hear me? Somebody can quickly type in the chat box. Yeah. But Dharanish is not answering. Okay. Joshua, you can answer. I don't want to trouble you, Avinash. Don't worry. Joshua, you can unmute your both audio and video and answer. Joshua, are you there? You can unmute both audio and video. Jawahar, you can answer.
Yes, sir.
Yeah.
Sir, question.
Question, that is m2 dv2, one equation we have written, m2 dv2 by dt. Can you read the equation from your note? Last class we have written unmute both video and audio.
No, sir.
Yeah, go ahead. I am hearing you. Don't worry. You answer the question. You unmute both video and audio. Not answering. I call somebody else. Yeah, Jivita, you can unmute and answer. Jivita, you read the equation. Jivita, are you there? Hello? Jivita, are you there? Hello? Hello? Jivita is also not there, I think. Kannan? Kannan, are you there? Sir, can you hear my voice, sir? Nagaraj sir.
Sir, audible, sir.
But people are not
Yes, yes,
answering,
audible,
sir.
sir. Your voice is audible.
Yeah, nobody is there, I think. Not answering. Kannan, you can unmute and answer.
At least tell you don't know the answer, please.
You read the equation from the note. I am not asking a question. I am asking you to read the question from your note. That's all. Kirtivasan, have you written the notes of previous class? Kirtivasan. Nobody is responding. Kirtivasan, whether I have written the equation or not, Meenakshi Sundaram, you can answer.
Sir, yes, sir. You written the equation, sir.
Yeah, that is the doubt. If nobody is answering means I have not written. I have a doubt. Okay, can you please read the equation? M2 dV2 by
Yes,
dt.
sir. M2 into dV2 by dt plus V2 into V2 plus
Yes.
V12 into V2 minus V1 plus
Okay.
K2 into integral of V2 into dt
Okay.
plus K1 into integral of V2 minus V1 into dt equals 0.
Very good. Very good. Thank you. Thank you, Meenakshi Sundaram. Thank you. So I have a doubt, but nobody is answering. Okay. Now you please listen now. In your note, that is last class we have written the mechanical translational equation. So the first term is m2 dv2 by dt. The equivalent, the analogous term is, we can say, the analogous term is L2 into dA2 by dt plus B2 V2. For B2 V2, for B what is the equivalent? For B what is the equivalent? The equivalent is R2. Equivalent is R2. So R2 I2, R2 I2 plus 1 by C2. K2, it is 1 by C2 integral I2 I2 dt. Okay. Plus R12, B12, the term is the equivalent term in mechanical translational system is B12. So B12, V2 minus V1. There V is the mechanical system, the V is velocity, not voltage. Okay. And the last term, 1 by C1 integral I2 minus I1 dt equal to 0. Why there is a 0 here? Yes, there is no applied force or applied voltage in this loop. Applied force in the mass 2. There is no applied force in the mass 2. That is why there is no applied voltage in the loop 2. So this is the thing. Okay. So this is electrical force voltage analogous circuit and force voltage analogous equations. Okay. Now we move to force current analogous circuit. What I have drawn, once again I redraw and write the equation. You please listen. Force current analogous force current. Able to see circuit, the word circuit. You can answer. Okay, I draw the circuit. This is force current analogous circuit. C2. This also you have done. But once again, I'm rewriting the circuit. Okay. So force current analogous circuit. So I of t, C1, R1 here. Node 1, V1, node 1 I call, node 2, V2. Nodal equation. For current, force current analogy, we need to go for nodal equation. So then we use Kirchhoff's current law equation. So C1 dV1 dt plus 1 by R1 V1 plus 1 by R12 V1 minus V2 1 by L1 integral V1 minus V2 dt, that is equal to A of t. So this is for this node. Please listen. The elements, please listen to the circuit. This is the node 1, node 2. Node 1, the voltage is V1. So here, this is V1 and bottom is
Excuse me, sir.
0.
Sir?
So with respect to this bottom point, here the voltage is V1 and with respect to this 0, this portion, the voltage is V2. So now the current through
Sir,
this
can you hear?
capacitor is C1 dV1 by dt plus 1 by R1 V1 over. And please listen, if you have any doubts, you can unmute and ask me.
Sir, voice clear, sir.
This portion experiences two voltages, V1, V2. So when we write, as usual, when we write the equation for node 1, V1 is positive. When we write the equation for node 2, V2 is positive. You have to consider. So 1 by R12, V1 minus V2 plus 1 by L1 into integral V1 minus V2 dt equal to I of t. See, can you see the I of t? If somebody can answer, I of t? Surya Narayanan, you can answer. You can unmute and answer. Surya Narayanan? 139, Surya Narayanan. Yeah, can you see the I of t in the equation?
Yes, sir.
Okay. See, when you, okay. So, now I write the equation for V2, node 2. So, node 2, the equation C2 dV2 by dt plus 1 by R2 V2 plus L2. 1 by L2 integral V2 dt plus 1 by R12 V2 minus V1 plus 1 by R12. This 1 by
Hello, sir.
Sir? Sir? Raman, sir? Hello?
okay. 1 by R12 V2 minus V1 plus
Raman, sir? Hello, sir?
okay. C2 dV2 please listen. C2 C2 dV2 by dt plus 1 by R2 V2 plus 1 by L2 integral V2 dt. V2 dt. This experiences only this voltage V2. Only this voltage V2. And these two elements experiences, as we have discussed, voltage V1 and V2. We are writing the equation for node 2. So V2 is positive. So 1 by R12 V2 minus V1 plus 1 by L1 V2 minus V1 dt. V2 minus V1 dt. Okay. Right. Just a moment. Plus dt equal to 0 because there is no current in this V1 experiences input current, but here V2 no input current, so this is 0. Okay, so now you can compare one first order differential equation. You compare like this: one first order differential equation, okay, two integral equations, and this ordinary terms, two ordinary terms will be there. Okay, so that's all. So these two equations, the dV2, M2 dV2, that equation is analogous to this equation, and this equation is analogous to this equation. Therefore, these two are dual equation or analogous equation. Okay, so here voltage is the input, here current is the input. The terms are same. Two integral terms. First order differential terms 1. First order differential term 1. Okay. So any doubts? Students, you have any doubts? We move to next problem. Shall we move to next problem?
Sir, Raman, sir?
We call
Hello, sir? Can you hear me?
Dharan, you can unmute and answer. Is it clear? Dharan? Clear, Dharan? Hello? Okay. Turn towards the board, voice is breaking, but I am using Bluetooth. Okay. Now Now is my voice is clear or not?
Clear, sir.
Now I'm hearing your voice. Okay. Alright, sir.
Hello, sir.
Okay. Afternoon we do some other technique. Okay. Okay. Shall we move
Okay,
to
sir.
next problem? Simple problem. Okay.
Sir.
Is my voice audible? Somebody can unmute and answer. Is my voice audible?
Yes, sir. Yes, sir. Yes, sir.
Breaking. Hello?
No, sir, it is okay now. Raman, sir, it is okay now.
Just a moment. I do go for one more connection. Is it audible now?
Hello.
Nara, sir, is it audible?
Okay, sir, voice is okay now.
Hello? Voice is breaking. Just a moment. Just a moment. Is my voice audible, sir, now?
Yes, sir, okay now.
Sir, audible, sir.
Audible. But I am receiving messages. Just a moment. I do something.
Is my voice audible? Hello?
Sir, I think you have turned on two devices. Hello, sir.
Yes, sir. Yes, sir.
I think the speaker of two devices has been turned on.
Yeah. No, sir.
Sir, echo ஆகுது sir.
No, sir.
Now it is okay, sir.
We continue with this.
Yes, yes.
Okay, we take up another problem. Line B. Is it audible?
Yes, sir.
Okay, sir. This is the problem. Okay. Write the equations governing the mechanical system. Draw the force voltage and force current electrical analogous circuit and verify by writing mechanical writing mesh and nodal equations. So now you draw the diagram. K1, P1, K2, K3. Here we go. This is the problem. Now, what is your first step? First step is to draw the free-body diagram for mass one. Elements connected to M1 are K1, V1, K2, and M1 will have a force, opposing force, and the applied force is F1 of T. So four forces it is. Three elements will have three forces, and one force is for error.
Sir, Ramun, sir.
Yes, sir.
So voice is not audible, sir. Echo அடிக்கிற மாதிரி இருக்கு.
Cool. Now is it okay, sir?
இன்னும் அதே மாதிரி தான் சார் இருக்கு. ரொம்ப ஒரு டீப்பா ஒரு இடத்துல இருந்து பேசுற மாதிரி இருக்கு.
Sir?
ஓகே சார், ஓகே.
Hello?
ஓகே சார்.
Okay, sir. Okay, sir. So, M1, this is M1. M2,
There is
another applied force, two forces here.
F1
F1 of T, F2 of T. One, two, three, four. FM2. FM2. K3.
So are the three body diagrams. So I am straight away writing the velocity equation. I am not using displacement, I am using velocity.
F1 of t.
So
So
M1
M1
dV1
dV1
by
by
dt,
dt,
V1
V1
V1,
V1,
K1 into
K1 into
integral
integral
V1
V1
t,
t,
K1
K1
into
into
integral
integral
V1
V1
t.
t. Okay,
Here.
here. V2.
Here
And
you
here you
have
have V3, sorry, X3.
X3.
X3, V3.
So this is your
This is
first
your first
equation.
equation.
And second
And second
equation
equation
is
is,
for
for
this.
this,
See, if you are not
see, if you are
comfortable
not comfortable
with this
with
equation,
this equation, that is,
you start as
you
usual
start as usual
with the displacement
with the
equation.
displacement equation.
Then you
Sir, it
Then you
was.
replace
replace
Hello, sir.
velocity.
Right, you have any
Right, you have any
doubts?
doubts?
சார்
Any doubts?
Any doubts?
சார் வாய்ஸ் ரெண்டு தடவை கேக்குது சார். ரெண்டு டிவைஸ் ஆன் ஆயிருக்கு உங்களோட.
ரெண்டு ஆன் ஆகலையே.
ரெண்டு ப்ரொஃபைல்லையுமே ஸ்பீக்கர் ஆன் ஆயிருக்கு.
எப்படி என்னுடைய தெரியல.
Now,
Now, is it
இப்போ
okay,
ஒரு
sir?
இதில் ஆஃப் பண்ணிட்டீங்க. ஓகே சார், கிளியர்.
Okay. Okay. ஒரே குழப்பம். Okay. So please listen. Yeah, now it's Nara sir.
ரொம்ப கிளியரா இருக்கு சார்.
Okay, good. This is what I want. So now please listen. Please, if you are not comfortable at this point, you write the previous equation. That is equations with the displacement. Then you convert with velocity. Convert with velocity. Okay. So V2 minus V3, V2 minus V3 dt equal to F2 of t. You have any doubts? Please ask me. Please stop at any point and ask me questions. So now I write. You copy this. Please copy this.
Hello. Is it audible, sir? Nara, sir?
ஆடிபிள் சார், ஆடிபிள்.
Just a moment, sir. For me, it is not audible.
ஓகே.
Yeah. So now I write the equation for mass 3. So please listen, I explain. M1, we have three, refer your note. In the problem, you have three masses. Mass 1, mass 2, mass 3. So we have three equations. And in force voltage analogy, we have three loops. And force current equation, we have three nodes. Okay, are the things. So first equation, m1, m1. m1 normally how do we write? m1 d square x1 by dt square. Okay, but we know that the differentiation of one step. Okay, differentiation. First order differentiation of velocity is acceleration. Second order differentiation of displacement is acceleration. Okay, that we have discussed. So I am using velocity. So m1 dv1 by dt plus bv1 b term bv1 plus k1 into v1 dt k1 because k1 is connected only to mass 1. Refer your note until I am speaking to you from the equation. Okay, m1 dv1 by dt and v1 is connected only to mass 1 and k1 is connected only to mass 1. K2 is connected to both mass 1 and mass 2. K2 is connected to both mass 1 and mass 2. So K2 into integral v1 minus v2 dt. And the applied force is F1 of t. Applied force is F1 of t. Second mass m2 dv2 by dt plus b3 v2 minus v3 b3 is connected to m2 and m3. Refer your note. And k2 is connected to v1 and v2 so k2 is integral v2 minus v1 dt plus k3 is connected to both m2 and m3 so this is k3 into integral v2 minus v3 equal to dt, that is equal to f2 of t, because there is another applied force on m2. Now we come to mass 3. Mass 3 has three opposing forces. So one is from mass 3 itself, m3 dv3 by dt, and b3 is connected to mass 2 and mass 3. So b3 minus v2 plus k3 is connected to mass 3 and mass 2. So k3 integral v3 minus v2 dt equal to 0 are the three equations. Any doubts, students? Please ask me or say yes. Somebody can unmute and say yes. Hello?
Yes, sir, no doubt.
Yes, sir.
Okay. Yeah, we proceed further. Now, so we have this much knowledge. Now we move to we have three masses in mechanical system. How many loops will be there in case of force voltage analogy? How many loops will be there in case of force voltage analogy? How many loops we will have?
3, sir.
3. Okay. And in force current analogy, we will have three nodes. That you have to remember. The procedure and all, if you read the book, it looks complicated, but actually it is simple. So now I am erasing this. I erase this first. Okay. So first we start with force voltage analogy. Force voltage. Shall I erase the problem? This is also not necessary. Okay. So now force voltage analogy. So we have inputs. First we Naresh sir, am I audible?
Yes, sir.
Okay, sir. So force voltage analogous circuit I am drawing now. F1 of T is mechanical input that is connected with mass 1. Okay. The equivalent or analogous term in force voltage analogy is E1 of T. E1 of T. And F2 of T is another applied force that is on mass 2. So here we have the equivalent is or analogous term is E2 of T. We have three velocities, three masses, three velocities. V1, V2, V3. So this is I1, I2, equivalent is I3. Okay. So mass 1, the equivalent is L1. Mass 2, equivalent is L2. And mass 3 masses we have. The idea is very simple. M3, L3. B1, R1, B3, R3. Okay. And K1, 1 by C1, K2, 1 by C2, K3, 1 by C3. Okay. So all terms are available here. All terms are available here. So now we, please listen. This is input, independent variable. That's what we have written in the table. Independent variable input, and this is output. Three outputs, three loops, three currents, and mass storage element. This is a dissipative element. This is another storage element. The K is storage element. The equivalent is our analogous term in force voltage is 1 by C1, 1 by C in general. So now I am okay. So now I am drawing the equivalent circuit. Okay. Now B section people can answer. B section people can answer. I call by number. I cannot see your name now, time being. Okay, I call by number. 202, you can answer. The elements connected only to mass 1. What are the elements connected only to mass 1?
K1.
K1. K1. I mark it with green color. K1. Okay.
B1.
B1. B1. Okay.
F1 of T.
Then, pardon me.
F1 of T. Force.
F1 of T is the force. Okay. F1 of T. Then, okay. Then mass also we have to consider. Mass M1. Okay, is it clear?
Yes, sir.
Yeah. Okay. So now, please start drawing. Applied input E1 of T. Applied input E1 of T. The elements connected only to, you have to connect all the elements in series. All the elements in series. Elements connected only to mass 1. So first you draw mass 1. Mass 1, L1. Then R1. Then C1. That's all. Now you tell me the elements connected to mass 208. 208, you tell me elements connected to mass 2,
Sir.
mass 1 and mass 2.
Hello, sir.
Yeah, mass 1 and mass 2. What is connected to mass 1 and mass 2? Elements which are common between mass 1 and mass 2.
Sir, கேக்குதா?
You refer the diagram and
கேக்குதா சார்?
கேக்குது. Go ahead. Hello? 210, you can answer 210. Hello, is it audible? Nara sir, is it audible?
Yes, sir. Audible, sir.
Okay, 210, 211, 211, 212.
Sir.
My question is, my question is elements which are common to mass 1 and mass 2. That is my question, very simple question. You refer your diagram and tell me the answer. Nothing new. What is common to mass 1 and mass 2? What is connected between mass 1 and mass 2? Okay?
K2, sir. K2.
That's what I want. K2. So you connect the term which is common to loop 1 and loop 2. Now we go for E2 of t. This arm is for the terms, for the elements which are connected only to, because please listen, this is the only portion which is connected to this mass 1, mass 2. So this is I2. So because this arm is common to loop 1 and loop 2, and this arm is common to loop 2 and loop 3. Loop 2 and loop 3. This is the only portion which is connected only to loop 2. Only to loop 2. So loop 2, L2. L2 is there. Okay. Time is going. It is moving fast. So I have to go fast. So it is R3 or R2. It is R3 or R2, check it up. R3. So it must be B3. Okay. And here we have L2. C3, R3, L2. Okay. This is the force voltage equation. This is the analogous circuit. Analogous circuit. So if I write the equation, equation will be L1 di1 by dt plus R1 I1 plus 1 by C1 integral I1 dt plus 1 by C2 integral I1 minus I2 dt equal to E1 of t. This is the first equation for loop 1. Please listen. L1 di1 by dt, R1 I1 C1, 1 by C1 integral I1 t, and this is common to I1 and I2, that is loop 1 and loop 2. So 1 by C2 into integral I1 minus I2 dt. The applied voltage is E1 of t. Any doubts? Okay, we move to loop 2. So loop 2 equation I write here. E2 of t. Please listen. I consider this loop. Please, I consider this loop L2 di2 by dt, and this is R3 I2 here I3. I2 minus I3 plus 1 by C3 I2 minus I3 dt plus 1 by C2. This is common to I1 loop 1 and loop 2. So I1 I2 minus I1 dt, and the applied voltage is E2 of t. Now I write the equation for this. L3 di3 by dt plus R3 I3 minus I2 R3 plus 1 by C3 I3 I2. Okay, I explain. Please listen. Here it is L3. So L3 di3 dt, L3 di3, L3 di3 dt, R3 I3 minus I2, I3 minus I2 plus 1 by C3 I3 minus I2. There is no applied voltage. It is 0. It is 0. Now, so it is yeah. Similarly, we need to write the force current analogous circuit. Okay, now you can compare these three equations. The main idea is you can compare the mechanical equation 1 with the loop equation, force voltage equation 1. And second equation, compare it with the second equation. And third equation, you compare it with the third equation. So now we take up to force current. Quickly we complete. Students, can you hear me now? Is it audible?
Yes, sir. Audible, sir.
Okay, okay. So now we move to force current analysis. Afternoon also we have control system class. So kindly join the class in time after your lunch. So have a light lunch. Okay. Otherwise you will sleep. Okay. Force current. So force current F1 of t is I1 of t, I1 of t, and F2 of t, F2 of t, it is I2 of t, I2 of t, velocity 1, velocity 2, velocity 3, voltage 1, voltage 2, voltage 3, voltage 3, and M1, C1, M2, C2, M3, C3. This is from the table. Okay. I'm not writing on my own. It is from the table. So you have to remember the table. One by R3. K1, it is 1 by L1. K2, 1 by L2. K3, 1 by L3. This is L2. Okay. So what is the time now, sir? Naraj sir? Is it okay? Hello? Naraj sir? 12:42.
Sir, it's 12:42, sir.
Yes, sir. Yes, sir. I'm hearing,
Sir?
sir. Hearing, sir. So, okay, 3 minutes more. We complete. So we have 3 nodes now. We have 3 nodes. V1, V2, V3, something like this. Okay. Circuit we complete. So this is I of t. So now you connect everything in parallel. The elements connected to mass 1, equivalent elements. This is very similar, 3 elements. Okay, C1, mass 1, R1 is there, B1, R1. So R1 you put it here, L1, where is L1? Spring 1, so L1. Are the 3 elements connected only to mass 2? So are the 3 elements, here you have to connect the elements in parallel. In case of force voltage analogy, you connect all the elements in series, but here in current analogous circuit, we have to connect everything in parallel. So now node 2, so L2, spring is connected between, spring only, no? Yeah, spring K2. K2 is connected between V1 and V2. Okay. And with V2, we have a input I2 of t, current source connected. And we have another capacitor. There is capacitor in the sense here mass 2. Mass 2 is connected, or some V2 mass 2 is connected. Now V3. So here you connect the elements in parallel. That is elements which are common to both M1 and M2. M1 and M2. So R3, L3, and here you have M3. That's all. So afternoon we have control system class only. Okay, we write the equation and we solve one more problem in rotational system. Then we move to block diagram reduction technique. Okay, any doubts, students?
No, sir.
Okay. So we follow the same thing. Okay, we continue at 2 o'clock. Thank you very much. Thank you, Nagaraj sir. Sir, next class 2 o'clock then, sir.
ஆமா சார் 2 மணிக்கு.
Okay, sir. Thank you, sir.